Okay, so good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects on creating a thinking math classroom. It's the part 3 with Laura Ginny Newman. We have a fairly small group tonight, but it's always good to foster participation, and it's always nice to see enthusiastic teachers that are joining us to share their ideas and discover new and exciting things. Je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Cette session est en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à me contacter par la suite. We are definitely thrilled to have each and every one of you with us, and it is also our absolute pleasure to welcome Laura Ginny Newman. Let me go to our first slide. Laura is a member of the Critical Thinking Consortium, also known as TC Square, and she's currently working on the development of a number of resources to support the implementation of critical thinking in the teaching and learning of mathematics. If you attended part 1 and 2 of her presentation, you will certainly appreciate the privilege we have to have Laura with us again tonight. So at this point, without further ado, I will pass the microphone to Laura and let her keep introducing herself, as well as the research she has conducted in the fields of mathematics. Laura, please feel free to click on your talk button now to turn your microphone on, and then go ahead anytime you wish. The class is yours. So remember to click on your talk button, and yeah.
Thank you very much.
Excellent, thank you.
Thank you, and welcome everyone to the third session. I'm going to do a little bit of a sound check as well, and just ask people to let me know if my voice is clear and if it's loud enough and you can hear me well. So again, I'll ask you just to show a thumbs up if that's the case, that everything is good, and my voice is clear and the sound is good. Okay, so I'm seeing a few thumbs up. I'm hoping that everybody else is okay. At any point in time during the presentation, please don't hesitate to let me know that perhaps the sound is a little bit iffy, or if it's not clear. Also let me know if there's anything that you need me to repeat or go back to. Or if there's anything, any questions that you might have, please don't hesitate to jump in and ask those questions. The important part of our sessions is always about your learning, and I want to begin by thanking everyone for joining the session tonight. I know that the weather's getting nicer out there. We want to be outside. Your children probably want to be outside, and I also recognize that it's a very busy time of year in your schools. So thank you for taking the time out to do some professional learning around critical thinking and creating a thinking math classroom. And for those of you who were unable to attend all 3 sessions, or particularly the second session, what I'd like to do is, although the focus of this session is going to be on assessing critical thinking through the processes, there was a little bit of the second session that we didn't quite complete, and so I want to start there and make sure that that kind of begins and frames our learning for the session today. So for those of you who who weren't able to attend the session, the last session we were looking at the tools that support the thinking in the mathematical processes, and we actually looked at 6 of the mathematical processes and left problem solving as the last one. So this evening we're going to take a look at problem solving, and the question that we were answering was, do the intellectual tools of an effective critical thinking support the proficient use of the mathematical processes? And in general, as people engaged in the thinking that I invited them to do and responded to answer this particular question and give us a sense of you know, where they thought all the intellectual tools fell. for the most part, showed that the responses weighted heavily towards absolutely, that some or all of the intellectual tools played a role in developing proficiency in the mathematical processes for our students. So what I'd like to do is now move to the last mathematical process, which is problem solving. And I left this for the last one for a particular reason, and that's that I thought it was probably the one that's most interesting for us to think about in terms of the degree to which it relates to all the other mathematical processes, and in that sense would give us a clear sense of the importance of the intellectual tool as a way to consolidate our learning. So you can see here that the definition of problem solving as a process is taken right from the Ontario Ministry curriculum documents, is stated here that problem solving is about the developing, selecting, applying, and comparing a variety of problem solving strategies as students pose and solve problems and conduct investigations to help deepen their mathematical understanding. What I'd like to begin our session with is by asking you to think about how does this mathematical process relate to the others? And we're going to do that with a focus on criteria, because you've probably noticed that central to engaging in critical thinking in math is the use of criteria that helps guide the students' thinking, so that we focus on quality thinking rather than just students engaging in any type of thinking. And that's not to say that it's not important that our students engage in thinking and feel successful that they can, but we want to make sure that they are actually achieving success and achieving proficiency and their ability to think in a quality way in the mathematics classroom. So having said that, what I would like to do is explore this relationship through the use of a couple of examples. And so you'll see here on the following slide, what I've done is I've taken an example from the grade 9 EQAO test. It's a sample question from the 2015 EQAO test. And I've adopted it somewhat. You'll notice that the question, the following graph represents the relationship between Kenny's distance from home on a bike ride and time, and the graph is given. That part of the question is precisely how it reads and what shows up on the EQAO test. And what I've done slightly differently is on the EQAO test, students are given a table and they're asked to provide that description by completing a table, and the table asks them to record for each of the different segments on this line graph, to record for each of the sections the distance that was traveled, the time, the direction, and the speed. What I did was I tried to look at the nature of the thinking that was required by the students to be successful in the EQAO test, and I scaffolded the EQAO question with a question that you'll see in a minute. I don't want to give too much details, but my intention was to scaffold. So the question that I changed it to, as opposed to just recording in a table the students' findings, I've asked the students to describe Kenny's bike ride by comparing the different parts of his trip, and then to decide which parts of the bike ride would be most similar. And you'll see that there's one additional scaffolding question that I would use, and that's what piece of information would be most helpful in making this comparison. So what I would like to invite you to do at this point is, given the nature of the question, you've had a little bit of time just to look at it while I've been talking, is to spend some time thinking about what is the nature of the thinking involved, the thinking that the students have to engage in order for them to respond to, successfully and effectively respond to this question, and how does that thinking connect to the mathematical processes that we have been discussing over the last two sessions together. And I want to give you a little bit of time just to do that thinking. So I'd say let's take about a minute, and if perhaps Michelle can turn on the timer for a minute. And I want you to be thinking about, as the students respond to this particular question and task, which one of the 6 mathematical processes bring in the nature of the thinking involved for the students to be successful. And I'd like to give you a minute to do that. Now, hopefully that gave you enough time to do some independent thinking, and I'm going to ask you, as Farah's done, to, if you can place the mathematical processes that you believe represent the nature of the thinking that the students have to engage in the chat box. That'll allow everybody to see what the thoughts are of all of the participants in the group. So if you could take just a few minutes, just in the chat box, to put down what your thoughts are. Okay, so I'm seeing a range of different conclusions that people have identified. A lot of the different mathematical processes coming into play. Again, to invite you to engage in the thinking, I've set out a description of perhaps how each of the processes that we are considering might play a role. So I'm going to give you an opportunity to take a look at how I've described for the students, in order for them to create an effective description meeting the cognitive demands of the question that was being asked. This is how perhaps they've engaged in the different types of mathematical processes, and I invite you to consider how much this aligns with your thinking. Do you agree or disagree with these? Is there anything that you might change or that you might add? And if you want to do that thinking, you want to put some of your thoughts in the chat box so others can see it, that would be great. So any thoughts from the group? Do you agree or disagree with these? Is there anything that you thought about that is not on this list? Some thoughts that you had? Would you change some of the wording? Are there some additional ideas that you might include? Okay, thank you, Lisa. So definitely, perhaps communication might be the most important one. I've got Farah who's saying that reasoning improving is at the top of her list. So in the absence of the reasoning improving, we're not quite sure how well they're going to communicate the description. Any other thoughts from the group? Okay, interesting point. They might be able to reason and improve, but does that mean they can communicate effectively? And Terry's saying it's hard to separate them, which is interesting because what we're looking at here is at problem solving, and we're looking at how problem solving promotes quality thinking and procedural proficiency. So often when we get our students to engage in problem solving, there's a lot of thinking that needs to be taking place. And what we want to do is make sure that the students are engaging in thinking that is quality thinking. So you'll notice here that as you read through these different descriptions of the criteria, you'll see that these are very much qualitative in nature. That to reason and prove, students have to effectively assess. When they're reflecting, they're checking for reasonableness. When they're selecting tools and computational strategies, they're not just any tools or computational strategies, they're appropriate. Same as communication, we need appropriate conventions, symbols, words that they're choosing, and that they're effectively organizing those ideas. So if we look at this holistically, there's a lot going on to answer what appears to be a very, very, for many people, what might appear to be a very, very simple question. Here's a graph. I expect you to be able to take a look at it. And as the ministry or EQAO, as they presented it on the EQAO test as an open response questions, students had to engage in all of this thinking to be able to do that well. So it's really important that although they all work together and in unison, we really need to make sure that we're breaking this down for students a little bit, that we are focusing and targeting each of the mathematical processes and getting the students to understand that what needs to take place is quality type of work that we expect from them. So I want to talk a little bit about why I changed the question and the intentions behind the shifts and the changing the questions. The EQAO question is very much in many ways was what we call a procedural, computational, just connecting to background knowledge that they're pulling in, but doesn't really focus in on the thinking that the students need to engage in order to be able to answer the question. And much of the work that I do when I work with teachers is getting teachers to think about, so if you have this question, what's the nature of the thinking that's involved? How does it connect to the mathematical processes? And how does it connect to the mathematical processes that are important in answering the question and answering it well? And also, how do we ensure that the students understand what the nature of that thinking is in order for them to be proficient at applying each of those processes? So the question was changed because I really wanted to move from a focus that was more knowledge-based, computational, procedural, to a question that really invited students to think. And one of the interesting conclusions that many teachers draw as they engage in this type of activity is they find that, it doesn't matter what math question you ask, students need to engage in mathematical thinking, in quality mathematical thinking, to answer the question effectively, to answer the question well. So a really interesting way to kind of get us to be thinking about the role that the mathematical processes play, and a focus on the criteria and the importance of the criteria. Now, this brings us back to this question that we looked at in our last session, and this was the question that had us thinking about what role the intellectual tools play. So if many of you, and if you agreed with what you saw on the page, you can see that problem solving as a process really connects to and involves all the other processes. And as we talked last time, we saw that the intellectual tools were important. Some more important than others, but all of them were important to some degree in each of the mathematical processes. So if problem solving actually embeds all of the other mathematical processes, we can now see the significance and the importance of the intellectual tools and the role that they play to have our students engage proficiently in the mathematical process of problem solving. So I think that kind of brings together what we talked about in the last session, and for the folks who weren't able to make it to the last session, gives them a sense of a little bit of what we were talking about and what we were going through and thinking about in our last session. And it also gives us an opportunity to focus in on a little bit of what we really want to do in this session, and that's look at assessment. And I want to start here because if you recall, in each of our 3 sessions, you'll notice that I didn't give you an agenda of all the things that I'm going to think are important for you to learn. what I'm doing is I'm inviting you to think about the things that are important for us to learn and understand and think about as we teach mathematics and want to teach mathematics effectively. And so here I'm starting off with the question of how can we effectively assess through the processes? That's our driving question for the rest of the day together. And I wanted to highlight the importance of two things. That central to quality thinking in mathematics is the use of criteria, and we've seen that over the last two sessions together, but also central to student self-assessment and self-regulation, and for teachers, for assessment, is the use of success criteria. And we're all familiar with this idea of success criteria. It's something we've been asked to work with the ministry, and the ministry's done a wonderful job of saying we really need to communicate that success criteria and co-construct that success criteria with our students before they engage in any type of task that requires them to use the criteria. Now, because critical thinking and quality thinking in mathematics has a focus on criteria, it's really important that we're thinking about, so how do we get to that criteria on a day-to-day basis as students engage in learning about mathematics? Because as you saw in session 1 in particular, all the mathematical processes, and therefore all the doing of mathematics, the actions involved in mathematics, require the use of mathematical decision-making. And so the questions that I want us to be thinking about for the rest of the session today is to think about how related are these criteria, because I'm sure that all of you are thinking about how do I provide my students success criteria? What should that success criteria look like? And it's particularly important to guide their own self-assessment and self-regulation, but also important for teachers in the assessment of student work. And we've talked about, over two sessions, the importance of criteria to engage students in quality mathematical thinking. So I want us to be thinking about how are those two related, and once we've talked about that relationship, how useful is an understanding of this relationship for student and teacher use? How do we present it? How do we, is it important that students understand if there's a difference between the two, what the difference is, if there's not a difference? Just, I think, a really important conversation to move our work forward, and to what we often talk about in critical thinking is give students the tools to be able to become effective self-regulators and effective self-assessors, because really what they're doing in mathematics every day requires them to do that. So I want to start off again by asking you to engage your own initial thinking around this question, and to think about how related do you think that the criteria for quality thinking in mathematics are to your understanding and your using of success criteria, the criteria we use for the assessment of student work both by students and by teachers. And what I've provided here is a dashboard, and normally when I use an interactive whiteboard, I can show my arrow kind of moving around the dashboard. So I want you to kind of use your imagination tonight and imagine that what I'm asking you to do is take a position and decide where would you put that arrow in response to this question. Do you think that the criteria for quality thinking and success criteria are highly related? They're almost the same thing. They're very related. They share some of the same types of qualities. That they're somewhat related. They share some of the same types of qualities. And finally, well, they're not very related at all. They share only a few the same types of qualities, or a few similarities. And I want to give you about 30 seconds just to, based on your own prior knowledge and your own prior experience, and how you've used success criteria in the classroom and our discussions in your learning in the first two sessions around criteria for quality thinking, where would your thinking be placed on this dashboard? What position would you take? And I'm going to ask you to very quickly just choose a position, and I don't want it to be shared at this point. I think it's really important at this point that this is really where your thinking begins. And we will return to this again later on in the presentation. At that point, we'll share as a whole group. So I just want to give you 30 seconds, and maybe, Michelle, you can turn on the timer for us so people have 30 seconds to do this thinking. Okay, so hopefully you've chosen a position, and what I'd like to do now is very quickly bring to you just a reminder, because I'm sure you've seen this before, a reminder of the definition of success criteria by the Ontario Ministry of Education, and give you a moment just to review this definition. Now you'll notice that I've highlighted some of the important words here. The purpose of success criteria, why we use it, is to determine to what degree a learning goal has been achieved, what success looks like, and it allows both teachers and students to gather information about the quality of student learning. So you can see there's some really important wording here, the wording of to what degree and the quality of student learning, both words that we've used throughout the first two sessions together. So looking at things from the perspective of considering to what degree things have an impact, and also focus on quality. So I want to also share a definition from the Critical Thinking Consortium of quality thinking and the purpose of criteria for quality thinking. I'm going to give you a moment just to read that as well. And again, you've noticed I've highlighted some of the words that criteria is used to describe ways. So the purpose is to help students make good decisions. We spent a lot of time talking about that. Notice that they're dealing with problematic situations that invite students to make decisions, that students use qualitative criteria to make reasoned judgments. We want their judgments and decisions to be good judgments and decisions. And those judgments are used when they solve problems in mathematics to make those kinds of judgments that focus on the quality of their mathematical work. So the quality of their thinking in the mathematical and the quality of their doing of the mathematics. And we talked a lot about that in terms of the mathematical processes. I'm now going to invite you to engage in an activity. Applying those two definitions and some of the key ideas, I'd like you to think about which one of these different examples of criteria do you think reflect criteria for quality thinking? So when we talked about the criteria for quality thinking on the previous slide, I'd like you to identify, is it numbers 1, 2, 3, numbers 3, 4, 5? Which one of these, as you reflect on each one of these, which one of these helps students make reasoned judgments and help them to make judgments about the quality of their mathematical work? And I'm going to give you again, I'm going to say 2 minutes at this point, because you're going to have to be doing some thinking about each of these. So hopefully what we can do is set the timer again for 2 minutes. And I'd like you to think about each one of these statements and as examples of criteria, and which one of these do you think represent criteria for quality thinking? So now that you've had 2 minutes to do your thinking, I'm going to invite you to identify, using the numbers, which of these statements do you believe represent criteria for quality thinking? So if you can just put that in the chat box. Okay, so I'm saying Lisa thinks 4. Okay. Okay, so I'm seeing a lot of 3 and 4. Some people saying 1 to 4. 3, 4, and 5. And I'm actually very thrilled that many of you are highlighting number 4, because number 4 is really, really nicely pulls together all of the thinking that we've been doing over our sessions together. That really, when we want our students engaging in quality thinking, we want to make sure that that reasoning is sound, that they're considering all the feasible alternatives, and to arrive at a decision that is reasoned using appropriate criteria and mathematical evidence. So I'm so excited to see that. I'm wondering, however, in a more specific, less broader way, how some of you are identifying, and I've noticed that you've identified many of the others as representing quality thinking. So if we take a look at each one of these, one of the things that I want to highlight that is important is that as you look at each of these examples, the examples that have certain words that really highlight the fact that the students can engage in the thinking that you've identified in 4 is really what we're looking for. So let's take, for example, and I'm going to show you my next slide, because my next slide kind of highlights some of those words. So for example, if we ask students if their answer makes sense, then what we describe in number 4 really describes the nature of the thinking that they're doing, because they have to be engaging in accessing the relevant information, thinking about what's the criteria for sense making, how do I decide if something makes sense. So there's a decision inherent in the question, and in order to ensure that the decision is quality in nature, we want to make sure that there's criteria and the students are thinking about appropriate evidence, and they're thinking about how do I assess that? So there's an evaluative or an assessed component involved in that. Let's take, for example, many of you identified number 3. The solution states the problem, what is known and unknown, how it was solved, and draws a conclusion. You'll notice here I didn't highlight any words, any qualitative words in orange. And although we really encourage that students do this, and I'm not saying that it's not important, it's extremely important. If I were to describe this in the form of decision making, I would say that the students need to decide what the problem states, what is known and unknown, how it should be solved or how it was solved, and how they're coming, to decide on a response. And absolutely, those are all things that we want our students to be doing as they apply this, and I'd like to call this an organizer, as they apply this organizer, problem solving, and often we see it as a problem solving template. But I want you to notice that there's nothing qualitative about what it is that's in this description of this particular criteria. So if I wanted to change this and actually embed a qualitative component to it, for example, when I ask students what is known and unknown, in mathematics, for students to be successful, they need to not just decide what is unknown, but they need to decide what is the relevant information, what is the relevant mathematical evidence, and what is the evidence I don't have to consider? So this involves a sorting that is not clear in the wording of this. Tell me what is known or unknown. Many students have identified, I've seen this happening in many classrooms, where a student states a problem, what's known, what's unknown, they state how they solve it, and they're completely off track. So how do we make sure that we're engaging them in the thinking that all of you identified in number 4 so that they can do this in number 3 really, really well? Take a look at number 1 as well. Many of our math classrooms, we've been encouraged to ask students to represent something in another way, or represent this in as many different ways as you can. And it's not that this is not an important exercise for students to engage in. The problem is that this does not engage students in quality mathematical reasoning. So when we want them to represent a problem in another way, and I've got a hand up, so I'm just going to finish describing this in a second, and then Farrah, I'll let you ask your question. When we have students representing a problem in a different way, what's guiding their thinking? So what happens in many classrooms is the students choose a way to represent a problem that is easy for them, is in a way that they enjoy. So notice that the criteria that they use are very personal, preferential criteria. Those criteria are not criteria that we want students to be using if they are to learn to think effectively as a mathematician. So we might want to reword this as, what's an effective way to represent this problem? What's another effective way to represent the problem? Or as students have represented, this is a really great way to generate ideas, as students have represented a series of different, represented the problem in a series of different ways, and they could be the ways that they like or they enjoy or they find easy. Then we talk about, so what's the best way? What's the most effective way to represent this particular problem? That's when we get students engaged in quality mathematical reasoning and thinking. So Farrah, if you want to just go ahead and turn on your mic, we'd love to hear from you. I'd like to hear your question.
You need to click on your talk button, the top left button.
It looks like you're trying, but it's not coming through. Do you want to put your question in the chat box? Oh, excellent question. And the question here is, what about creativity? And I have to tell you, I'd probably have to do a whole other session around creativity, but I'm going to try to explain it in a nutshell. When we ask students to represent in more than one way, we are engaging them in generative thinking. They're coming up with what I like to describe as many options as they can to consider how they might represent or think about this problem. Remember that as you identified number 4, we have to remember that creative thinking is a form of critical thinking. That creative thinking is not just generating options, but it's also evaluating those options so that we identify which option meets the needs of the particular context of what it is that we're doing. So often when we think about creativity, we believe that creativity is the generation of options or a lot of different ideas. But creativity is coming up with a new way of doing something that has value by its very definition. The other important part of creativity that is central to the work in mathematics comes when we see students making new connections. So, and if you think about creativity and innovation, new ideas that have come about over history, over time, you'll realize that to a large extent, those ideas come from somebody else's ideas. Somebody has taken an existing idea and found a new way to connect something to that existing idea. And so what's important here, and when we discuss creativity, and like I said, creativity is almost an entire session on its own, but when we discuss creativity, we have to remember it's not just the generation of options, but the generation of options and considering which options have the greatest value in the context to meet a particular purpose. And also, we want to consider that a lot of creativity is a representation of making new connections, which is something that we want to encourage our students to be doing in the math classroom all the time. So in this case, because they're generating a series of options, imagine if your students represent a problem that when they go to actually solve the problem, that representation might be an effective representation, but it's not really the most useful to help them solve the problem. We need to be having them think about, in light of all of these different ways to represent the problem, which representation would you choose if you're a proficient mathematical thinker in order for them to effectively be able to successfully, effectively solve the problem. Okay? Yes, I'm talking about, that's also the case with strategies, absolutely, Linda, and I agree with you, but it's any time students, whether they're thinking about modeling, whether they're thinking about representing, whether they're thinking about selecting computational tools and strategies, whether they're, the students have to select many, many, many different things as they engage in quality mathematical thinking. So anytime we have them do that, absolutely we want to encourage them to generate as many options as possible. But what we also want to do to engage in that effective creative thinking is choose the ones that are the most useful, that have the greatest value in the context of mathematics. So I hope that helps a little bit. I don't want to spend too much time going through the others, but you can see very clearly that there are qualifiers, very clear qualifiers, that are identified in the other statements that make these very much statements that encourage students to engage in quality thinking and therefore provide them criteria for quality thinking. This brings us to the relationship of success criteria and the criteria for quality thinking. And what I'd like to do is ask you, all of you very quickly, if you were to go back to this list, there's a number of things in here as we have our students look at success criteria, and I want you to think about models of success criteria that I've seen being used in the classroom. How many of you identify success criteria that look like numbers 2, 4, 5, and 6 that really deal solely with qualitative aspects rather than just things that the students need to be able to do? And I'm just going to ask people to put in their chat box, if you had success criteria in your classroom, would they include all of these, or would they include only 2, 4, 5, and 6? So all, or just the ones that I've identified? Thank you. Okay, great. Okay, so what I'm seeing is many of you would include qualitative criteria, which I think is really, really important. And Terry, you're saying that you very rarely see any of these, and so most of the time what you see is students doing a checklist. And so what I want to highlight is the reason why that happens, by the way, is because according to the ministry's models and samples of success criteria, this is what we typically see. We see students, we see in the body of criteria for success, both what we call qualitative criteria, which is the criteria that you saw have the qualifier and really focus on quality. And we also see what we talk about as being descriptive criteria. And this is the checklist of things students must do. So if I went back to this list, I would most definitely say that in my list of things that students must do, or the students that I might want them to do, is if they're solving a problem, I think they most definitely need to be able to state the problem, what's known and unknown, how it's solved, and draw a conclusion. But notice that if I were to present this, this is very much a checklist. It describes the requirements, things that students are required to do in order for them to have success. But it doesn't describe the quality of the things that they need to do. So it doesn't give them a sense of the qualitative nature. And so what we typically see as success criteria is a combination of these two things. We see a list of what students need to do. I need to complete the following, and often we see them in I can statements. Okay, so something like if I went back to, and I'm going to choose a simple one, right? When I look at the graph's title, often I'll see, I have included a title on the graph. That's a requirement. To have an effective graph, it must include a title. In fact, it must include a title. It must include labels. There's a lot of elements of a graph that need to be included, but that doesn't get to the quality of the graph. Is the graph's title, even the title itself, for an effective title in a math context, say for a graph, it needs to be concise, it needs to be informative, and it needs to be appropriately presented. In other words, it needs to be positioned somewhere in the graph that represents a standard convention. Okay? This is how we get students engaged in quality work, rather than just simply saying, I did that, I did that, I did that. Whether they did it well or not is not something that the students are being encouraged to consider. And success criteria often embeds both. So what I'm hoping that we'll spend some time thinking about today is, how do we work with this? And I want to, before we do that, go back to your initial thinking. And this is where I want you to share your thoughts. When you initially thought, how related are criteria for quality thinking and success criteria? Where did you position yourself? What did you think? And has your thinking changed at this point? And I'd love for you to put in the chat box what you perhaps initially thought, and if your thinking has changed, or just a statement of, no, this is what I thought, and this is what I now believe. So if you can show your letters, A, B, C, or D, at the first letter being what you initially thought, and A, B, C, or D, the second letter being what you now think after we've discussed some of these ideas. And it would be great to hear from all of you through the chat box.
Laura, also to make it visual, they can actually select a letter A, B, C, D through the survey tool. There's a little A underneath their name, the fourth icon to the right.
Oh,
and they can
perfect.
select A, B, C, D, and then I'll be able
that would be fabulous.
I'll be able to show that. Yeah. So just select one of the four letters, and then I'll be able to post them on the slide.
So perhaps to use the survey tool, and I'm seeing folks are putting it in there, where do you stand now? Where is your thinking now? And I'm very grateful for seeing if there was a shift in thinking as well.
If you are on a tablet or an iPhone, you have to actually click on the icon to select the A, the B, or the C. So hope it's working for everyone.
Okay, so I'm seeing a little bit of a shift from A to B. I'm seeing that now you're sitting at B a little bit more. And we're seeing our results coming up here, which is fabulous. Okay, great. Thank you very much for sharing that. So I'm seeing that many of you are sitting at A, some of you are sitting at B. What I'm happy to see is nobody's sitting at C. So what I'd like to do is now take a look at our next question in light of your understanding and consider how useful your understanding of this relationship is for student and teacher use. And again, what I want to do is I want to offer an example that has some thinking. And I'm sorry, I'm going to apologize just very quickly. I've got a dog barking in my room, and I'm going to get the dog out of the room for a moment. So I'll be back in 2 minutes. Sorry, 2 seconds. Hi, sorry about that. Unforeseen challenges. So what I'd like to do, what I'd like to do now is look at the following question: how useful is the understanding of this relationship? And again, I want to encourage thank you. The dog is it's a puppy, and it's got a lot of energy, and it's always trying to get everybody's attention all the time. So I needed to make sure that the distraction left the room, and it has left the room now. So thank you for your patience. And so through this example, and again, what I've done here is I've chosen a particular example of an invitation for students to think critically. And what I want to do is now draw on our understanding of the relationship between criteria for quality thinking and success criteria to see how would we create that criteria for students in response to this particular task. So hopefully, as I'm chatting away here, you're taking an opportunity to read through the details of this question. I am going to give you some time to think about it. I want to highlight a few things. One is that the question is asking, and also contextualize a few things. This comes from a classroom with some teachers that I've been working with for some time. And before the students got to this question, they had constructed an understanding of the properties of a linear relation. They had seen many examples of linear and nonlinear relations in order to construct that understanding. They also had constructed their own models of linear relations, and to kind of bring that thinking, to consolidate that thinking and to do a diagnostic of where students were at after all of that work, the teachers decided to ask the following question: is this an effective model of a linear relation? And students were asked to choose whether it was highly effective, somewhat effective, and not effective at all. And as part of the conversation, the criteria for an effective model was surfaced with the students. And you can see here the print might be quite small, but what the students identified as being important criteria was that the model was effective if it was an accurate and precise representation, and if it was flexible, that it held true under many cases or under various assumptions. The task they were given to contextualize their learning is they were told this is a model of a linear relation that McGraw-Hill-Ryerson is considering including in their textbook, and the students were to take a position on making a recommendation to convince McGraw-Hill-Ryerson if they should or should not include this. Now, before we actually talk about criteria related to the mathematical processes, I also want to show you the thinking strategy the students were given to help support their thinking, and they were given something titled an assumptions chart. And so you can see here in an assumptions chart, students were encouraged to make their assumptions very clear, and then based on their assumptions, clearly communicate what their conclusion was. So did they decide it was highly, somewhat, or little or not at all effective? And what was their justification? So how did they use their background knowledge, all of their learning around the properties, and all of the evidence that they're provided in order to come up with a justification? Now you'll notice here that I just put down two examples of assumptions students made. Some of the assumptions students made were, some of them said the colors have no meaning, so I'm going to interpret this model that way. Some of them said, well, the blues can be negatives, the purples can be positives, or vice versa. Some of them said, I can look at each of these holistically as a set, where the first set is term 1, the second set is term 2. So there is various interpretations and various assumptions that were being made. The conversation was very rich, very exciting. So what I'd like to do is give you an opportunity to take a moment right now and to think about what we had discussed previously in terms of descriptive criteria and qualitative criteria. What criteria would the students find useful as success criteria, and what criteria in that success criteria would you identify as being qualitative, and what criteria would you identify as being descriptive, as in requirements that you put on a checklist that students need to consider? And I want to give you a minute or so to do that thinking independently, and then I'm going to move on and share some thoughts. Now, if it's helpful, I'm going to put it back to this slide so you can see the whole question and task that's involved. As you're doing your thinking and you're taking time to generate some ideas, I'd love for you to put in the chat box some of the criteria you might come up with. And if you can make clear to everyone in the group, is your criteria requirement, is it descriptive, or is your criteria qualitative? And as well, I'm going to invite you to think about what are the connections to the mathematical processes involved here. So maybe we can start there. Can I just ask all of you to quickly, just in the chat box, let me know which mathematical processes are coming into play and having to respond to this question. Okay, reasoning improving, absolutely. Communicating. Okay, I'm seeing reasoning improving again. Okay, I'm seeing that all of them are coming into play. And I have to agree with many of you. I think that some of you identified when you said reasoning, improving, or communicating, you were targeting a particular mathematical process. Absolutely, what's involved in students successfully addressing this question and actually providing a recommendation, I would say for the most part, requires communication, representing, and reasoning improving as the ones that are of the greatest significance. Not that not all of them are playing some kind of role, because the students are obviously connecting to other models that they've thought about, other ways of representing the same thing. But probably those three, if I were to target any of the mathematical processes, because remember, to make the thinking manageable for students, although I've offered a very, very rich question that invites a lot of thinking on behalf of the students, I want to ensure that as I break it down for kids, for students, that I'm being very targeted so that the cognitive demands are not too high for them. So let's imagine that I chose representing as the mathematical process I want to focus in on for my students. Now, I don't know if you recall, oh, sorry, can everybody else hear me? So I'm just seeing Debbie said that she can't hear me. I'm back, perfect. Okay, great, thank you. So you'll notice here on the right-hand side, under the actual visual of the model, there's a series of statements that say what the students need to decide. And you probably don't remember this, I'm not sure if you do, but when we talked about representing on the very first session, these are the decisions we highlighted were needed for students to be representing. And if we went right back to the ministry's definition as a process expectation, and we broke it down into decisions students needed to make, and this is what we kind of talked about and shared. Now, as we take a look at each one of these, you'll notice that the students need to be able to decide what the representation is showing. So what does this representation mean? They have to decide how similar and different. So this is for those of you who looked at the mathematical process of connections, making connections. This is a little bit of that the students are connecting this representation, this model, with other models that they can think about. And the students need to be thinking about are there different ideas are there different ways that this can be interpreted? And that's them considering, under all cases, is the model flexible? These are the decisions we talked about earlier. You'll notice now that if I have criteria for judging the effectiveness of the model, my criteria relates to each of these decisions. So the first one, if I'm actually trying to come up with something that's communicating particular meaning, I want to know whether it's an accurate or precise representation of that particular idea that's being communicated. So it connects to the first one. I also want students to think about, is this model consistent with other representations of the same mathematical idea or concept? And this is where they're also making some connections. And I want them to also think about how flexible the model is. So can it be interpreted in different ways? Or as I interpret it in different ways, does it have the same meaning? So if you go back to the criteria the students identified, they did a pretty good job at highlighting criteria for an effective model. But as they worked on completing the assumptions chart, in their justification section, they began to notice that the second criteria was also important. It's hard for me to judge and justify whether this is an effective model if I don't connect this to other ways of representing the same idea. Now, the beauty of what we just did here is you'll notice, I'm gonna come back to the other one in a second, is, oh, hold on. I'm skipping over to see if I can get to where I want to go. Oh, it's not here. Okay, so what I wanted to show you that's really, really important is that if I take these and I take these criteria, when I ask students, what decisions do you need to make in order to solve this? What mathematical decisions? These are requirements. I need to decide this. I've checked it off. I need to decide this. I've checked it off. I need to decide this. I've checked it off. And so you'll notice that typically we state I can statements in the form of a list of things students need to do. This shift in thinking is really helpful for students, and I wanted to share it with you. I'm sorry, I'm being interrupted by my dog again. If you could just take some time. What I'm going to do is give you a moment just to take a look at the qualitative criteria the connection between the two, and that these are the I can statements can be written as decisions, and the qualitative criteria are related to each of the decisions. And again, I'll be back in 1 second. I'm sorry. Let's go. Let's go.
Hi everyone. So I have a dog as well, by the way. She's a bit older than Laura's puppy, I guess. She's like 5, 6 years old and sleeping peacefully next to me. But that's always one of my big anxiety when I'm moderating for TF is that what would happen if my dog sees a squirrel? I mean, I guess at night there aren't any squirrels, but she can go crazy from time to time. So I can sympathize and understand. It's not easy.
Oh, thank you. I'm sorry. I'm back again. I made sure I got my daughter to make sure we're not interrupted again. It's a Samoyed, and it's a beautiful, lovable dog, but it really loves a lot of attention, and it's constantly coming in the room saying, I need your attention, I need your attention, so I apologize. Difficult for me to present my ideas when I've got a dog barking next to me, though. So I'm curious, and I just want to know from the group if they can see a connection between I can statements and focusing the I can statements on decisions students need to make, mathematical decisions they need to make, and if it's clear that as we look at each decision they're going to make, we can look at qualitatively, how do we know they've made that decision well? So I'm just going to ask very quickly if this is making sense to people, if I can just see a thumbs up, or see if anybody has any questions. Because I know this is a real shift in thinking, but a really important shift in the work that we do in the classrooms with students. So if you can give me a thumbs up or a thumbs down if this is making sense to you, that would be really helpful for me at this point. Yes, Melanie. Okay, so I'm seeing some check marks. Oh, thank you. Thanks, Melanie. I just wanted to make sure that you didn't have something that you wanted to ask. So one of the things I wanted to share with you, as I've worked with teachers in classrooms, and I've done a lot of work all around the world, but one of the really significant shifts in thinking for students is seeing that as they solve mathematical problems, instead of, as if you remember the one statement that I said wasn't qualitative in nature, so state the problem. Teachers often complain that as students state the problem, all they do is reword the question or reword what's in the question. And often, if we want students to get to the meaning of the problem, we need to be asking them about what decisions they need to be making. So you've seen that in the first 2 sessions, that the mathematical processes are all about making mathematical decisions. So what we want to do is shift the thinking in the classroom so that we're beginning to ask students, so what did you have to decide as you were working on solving this problem? Or what would you have to decide if you were working on this problem? And it's really fascinating to see the shift in the way they identify the problem, really getting to the mathematics when we focus on the mathematical decision making. Now, the beauty in doing this is I now have students identifying, these are the things I need to think about. So this highlights the cognitive demands of the mathematical tasks or questions that we're asking students. And students are very good at saying, well, these are the decisions I have to make. And after they've identified the decisions, then we can talk about, just as we did with critical thinking, okay, so how are we going to make sure that you're making those decisions in a quality way? How do you make sure that those decisions, you're making those decisions, that those decisions are made well, that you've made good decisions. And this is a concept and idea that students really can get their heads around. I mean, part of it comes from, probably years of their parents saying, what were you thinking, or what kind of decision did you make? And it's really something that resonates with students and really helps them be able to generate their own criteria. So if I said, I have to decide this, how do I know that I've done it in a really good way, that it's effective, that it's going to make me successful, that I'm engaging in sound, reasonable, quality decision-making in mathematics? And Lisa, absolutely, I want to concur with you that this highlights the metacognition that is so important in math. And metacognition for many people, even when I work with teachers who are teaching mathematics, when we start talking about, let's get to the thinking that is behind the thinking students need to do, that's a really challenging task. But this is a really nice way to get students to really break this down and help students understand and see what's going on. Now, I'm not sure if if there's a question. Yes, Melissa, please jump in and just turn on your mic. And if your mic's not working, you have a question, don't hesitate to put it.
One of the success criteria and how this ties into.
Oh, I'm sorry, you cut out on me. I'm not sure if everybody else is hearing you. As I think Melissa might be typing in her question in the chat box, which is great. Okay, so one success criteria. Okay. I know when it is more appropriate to solve by factoring or solving by quadratic formula. So there is, see, that's fascinating because what you've highlighted is both the decision I need to make. So what's the decision that I need to make? I have to decide if I have to solve by factoring or by quadratic formula. How do I make that decision effectively? I have to think about which one's more appropriate in the context of the question. And I think that's a beautiful example. Now, notice how empowering it would be for your students to say, what's the decision? And they can really get their heads around what's the decision. I need to decide factoring or quadratic formula. Right? And then when you say, okay, so how do you know you've made that decision well? What do you need to think about to know you've made that decision well? And there's a number of, that's when you get to the criteria that helps them identify what's appropriate. So thank you for sharing that. Oh, you can't hear me, Michael? Oh, it's okay. Great. So I think your example is beautiful to have students then, when you're asking them the question, ask them to define what mathematical decision they're making, and then ask them to start thinking about, because remember, we want students to take ownership over the nature of this type of thinking. We want them to become independent at it over time. So it's really important that we make explicit for them how they can go about doing that and how they can engage in the thinking that they need to do when they're working on their own independently to be able to be successful. I wanted to highlight one other important difference. You'll notice here that the students were asked a question. They were asked, sorry, you can see in the corner, is this an effective model of a linear relation? But then they were also asked a task to make a recommendation to convince McGraw-Hill whether to include it or not include it. It's really, really important that we don't confuse for students the criteria for a quality product or performance and the criteria for quality mathematical thinking, the metacognitive part, even though both require that they make important decisions. So here, when I've asked them to make a recommendation, the mathematical process that they're engaged in is communication. And so notice I want to separate, and many of you said, well, representing is an important mathematical process here. Communicating is a reasoning and proving. And so for each of these, I want to make sure that I've chosen and targeted the ones that I really want them to focus in on, that are central to the problem. And I want them to be asking, in light of the fact that you have to make an effective, how do you make an effective recommendation? And that's your communication. That's the communication of your thinking and the structure you're going to use to communicate that thinking. And again, I need to ask, so if you're making an effective recommendation, what decisions do you need to make? Students are great at identifying the decisions. And then for each of those decisions, how do you know you're going to make it well? How are you going to make sure that you've done a good job at making each of these decisions? And this helps them create the qualitative criteria. So I want to share that example as well, because it's really important that we separate criteria that guides really the metacognition with the criteria that describes the thinking they have to do around product and performance. And when they're doing that, the product and performance, they're really engaging and communicating. So again, you can see I've just placed those statements as qualitative criteria versus I can statements, descriptive criteria. And I want to go back to just one other problem, because that really focused on a grade 9 problem. But the other problem that we looked at in the second session together was this particular swimming pool problem. And I have to tell you, I can't remember if I gave you the background on this, but this actually, the context of this came from a professor that was doing a session in Switzerland that I was also presenting at, and he was doing a session on creativity in math and creativity through constraints. And he was a professor from Oxford University, and he basically gave the students the question of a square swimming pool with trees that are in the four corners. And he said, you know, what would you have to do to be able to double the size? And he placed all sorts of constraints on the students. So you can't move the trees, you can't change, this has to remain a square, you can't turn it into a composite figure. And so when he was presenting it, I thought it was really interesting, this idea of constraint thinking to promote creative thinking in math, but I found it somewhat discouraging when you have to say to the students, well, that's a great idea, but you can't do that. That's a great idea, but you can't do that. So it was reframed this way by me, and I shared it with him, and he was actually quite excited by it. But what I really want to get to is the criteria for the question. Now, when the students, this is what he told me, when he actually used this. It was interesting. He told me that when he actually used this in the classroom, and he asks the students to highlight their thinking, the students immediately went to the decisions they have to make. And this is what the students said. Their descriptive criteria was, I have to decide on the size of the pool the community needs. I have to decide on the shape of the pool given the town's constraints. I have to decide how to protect the trees. And notice that qualitatively, their best course of action has to identify these following criteria. Whatever they recommend, it has to meet the community's needs, it needs to fit the town's construction constraints, and it has to be environmentally friendly. Notice how well this really connects with the mathematical process of making connections, which is the one thing I talked about is really, really important in math if we want students to engage in creative thinking. And by the way, every time we ask students to solve a problem that is unknown to them so that they're connecting what they've learned to a new situation and a new context, we are inviting them to engage in innovative creative thinking. And so it's important that we understand that that's in fact the case, that almost everything that we do in math really requires students to engage in that type of innovative creative thinking through the making of connections. But what I wanted to highlight here again is how beautifully this worked out. And my recommendation for him is, he said, well, they came up with the decisions. I said, absolutely, because the decisions really identified the math that they needed to do. So for example, when the student says the size of the pool, you know, I have to decide on the size of the pool needed by the community, they had to go back to the problem and they have to say, okay, how do I decide on the size? And so this is where they got to, many of the students then even refined this decision. Many of them said, well, I have to decide how I'm going to double the size of the pool. So notice that we get to accuracy and precision by getting the students thinking about the descriptive criteria, and we get to quality by getting the students think about the qualitative criteria that they need to use. So I wanted to share that with you because it was something that we looked at last time, but didn't have a lot of time to think about, but also very exciting to share with you that this particular professor actually brought this into a classroom and really through his experience with the students highlighted the importance of this process and how it was very intuitive and natural for the students. I want to, before we close, then go back to this question: how useful is the understanding of this relationship for both students and for teachers? And I want to go back and give you some time to think about and share with us as a whole group whether this conversation about this relationship between descriptive and qualitative criteria is something that is important for students and important for teachers, and have you thinking about what are your thoughts at this point around this. So again, if you want to either, if you want to put up your hand and share your thoughts using the mic, or if you just want to post your thoughts in the chat box, where is your thinking at this point in terms of the use of criteria? For both student self-assessment and self-regulation, and for teacher use for assessment. Thank you, Melissa. I'm glad that it's done that for you. Absolutely. Student voice is critical to this because we want them constructing those criteria, because if they construct those criteria, they own the criteria and they know how to use them. So thank you very much, Farah, for that comment. Thank you. That's great. I'm so happy to see that. All right, so I'm noticing that we've got about 5 minutes. So what I want to do is go back to where we started. This was the goal and the intentions that we had for the majority of our session together. So I'm hoping that you've been able to answer these questions, and that answering these questions have been really helpful in helping you understand the driving question: how can we effectively assess through the mathematical processes? I want to highlight 2 very important keys in promoting the effective use of criteria by teachers and students in the math classroom. The first is that we really need to focus on quality decision making, because if we do that, it helps students understand how to make good decisions while fulfilling the requirements, the cognitive demands of any mathematical problem that they have to solve. The second is that we have to align that quality decision making to the mathematical processes, because it's those processes that really describe the actions and the doing of mathematics, and our objective as math educators is to ensure that students can do the mathematics really well. So if there are 2 things that you leave in this session, I'm hoping that you're going to continue to think about is these 2 keys, and incorporating these 2 keys into your assessment practices, both for student self-assessment and regulation, and both for the assessment practices that you use in assessing your students. I want to close the session by offering you an opportunity to know that OTF is going to be offering 3-day summer institutes. One of those institutes I'm hoping I'm going to be able to run if there's enough demand for it, and it's on creating a thinking mathematics classroom, but really a more broader focus on how do we take all the ideas that you've started to think about now, refine how to invite students to think critically, but also how do we create ongoing inquiry in our classroom so students can experience the awe and wonder of mathematics, and in a very sequence-connected way continuously have us invite them through scaffolded thinking opportunities to to develop their learning and develop growth in their learning. So if you're interested, if there's enough participation interest, there'll be 2 sessions being offered, one July 20th to the 22nd in Niagara Falls, and the other August 3rd to 5th in London. And I don't know, perhaps, Michelle, you can add a little bit more or let us know where this information will be posted for OTF. I don't know if you're familiar with it, but that might be helpful. Is there anything that you know about the Summer Institute?
Yes, I'll actually post a slide at the end of the presentation and some links where people can go and have a look. So I'll talk about that in a minute.
Great, thank you. And it's going to include some of what we did today, but give teachers more time to really digest it, work with it, start developing their own materials around it. But also it's going to be broader because it's going to be a focus on critical inquiry in the math classroom. So a lot of the different things that you've seen me model around framing larger questions and sequencing smaller questions. How do we do that in our math classroom? Launching student thinking, encouraging student thinking so that students become proficient self-regulators, self-correctors, and that we nurture the habits of mind that are successful for students in the math classroom. So before Michelle ends the session, I just want to thank all of you for participating. I know how difficult it is to come into a session in the evening after you've done a full day of work, and especially today when the weather was really nice and I know there's a lot going on in your school. So thank you so much for joining us, and I wish you all a very fun-filled, sunny, warm, relaxing, and productive summer.
Thank you, Laura. Thank you so much for being patient and persistent and sharing your enthusiasm and your expertise with us. You managed to keep in control despite the small and furry external disturbance we experienced. As usual, at the end of one of Laura's presentation, I feel particularly enriched, and I must confess also slightly humbled. This was again a session of an extremely high level of skills and creativity. As always, I also want to thank all of you for being such incredibly motivated participants and dedicated teachers willing to take from your family time to be with us tonight. Let's go and look at what we have for the end of the season. These are the last sessions that we have planned before the summer holidays. Tomorrow we have an exciting presentation by my colleague Mali Bickley and Jim Carlton on using social media to explore global and social issues. It should be very exciting. On May 24, we have Peter Wright on financial literacy. On May 25th, there's a session by Brian Aspinall, but it's sold out, unfortunately. And on May 31st, we have, again, an exciting session on engineering by Lisa Lim Cole and Dave Doucette. So these are all the upcoming sessions, and you can obviously go on our calendar page to learn a bit more and to see what's still available until the end of the school year. Pour nos collègues francophones, nous avons 2 sessions en français planifiées dans les prochains jours. Ce sont aussi les dernières sessions pour la saison. La session de Suzanne Forrester le 30 mai, intitulée « Le français en tant que deuxième langue » sera essentiellement bilingue. Les interventions et questions en français et en anglais seront bienvenues. Et nous avons également une session le 1er juin intitulée « La Révolution française » ou l'utilisation de la technologie au cœur de la classe de français. Et cette session est présentée par Myriam Mallette et sera également bilingue avec prédominance du français. Both sessions will be fully bilingual, and I certainly invite you to participate if you can. Remember also to visit our resource page and our calendar page, and I will post these links right now in the chat box so that you can access them at your leisure. I also would like to tell you about another opportunity. You probably have seen that already in the past, but it's provided by OTF and the Ministry of Education. If you're a qualified teacher and completed an additional qualification course in math, technology or kindergarten, you may be eligible for a $450 subsidy, and I will post the link for you in the chat box as well so that you can access it. Next slide. So a couple of new announcements. As Laura indicated, OTF will once again be running 3-day summer institutes over the summer on revised curriculum, technology, and mathematics. And hopefully Laura will be able to facilitate one of these seminars for us. Registration just opened this Monday on May 16. And you can obtain more information by just visiting our OTF main page, the main page on our website. A technology conference is being offered towards the end of August, and you can also register for this starting this Friday, May 20th. And then finally, OTF is also pleased to offer its teacher learning cohort program, which provides teachers with the opportunity to obtain funds to support self-directed collaborative learning communities. And the deadline for submission is May 31st. All these are currently posted on the main page of the OTF website, along with additional information. I don't have the time to go into details, and I actually don't know all the details myself, but you will find all the information that you need on the OTF website. And we know that the spaces are filling up quickly, so you should mark these in your calendars and try to register. I'm posting here right now in the chat box the links that you would need to access in order to get more information about these 3 programs. As usual, we also would like to present you with an opportunity to give us your feedback on tonight's session and fill a short online questionnaire. The survey only takes a few minutes. If you could do it right after the session, it will be greatly appreciated. You should be redirected automatically to the survey page when quitting Blackboard. And again, I will paste the link in the chat box in case you are not redirected. Here's the link. This survey is very important for TF. We listen to your feedback and we pass it to our facilitator, and it also helps us with obtaining funding from the ministry for future OTF Connects programs. As a new feature as well, we would like to offer you a small bonus as a token of appreciation. Once you have completed the feedback questionnaire, you will be redirected to another page allowing you to enter your name, and you will then receive a certificate of participation to this training session that you can add to your learning resume. Please note that the certificate of participation is only available for 48 hours following this session. And if you don't have the time to complete the survey or fill up that form, don't worry either. We will be sending you in the next 24 hours a follow-up email with a link to this recorded session, to the feedback survey and archives presentation. I will also post in the chat box the link for Laura's presentation, part 3, that we followed tonight. So that's the link. It should be available tomorrow. The recording should be available tomorrow. I will now end the recording of the session. Please feel free to remain online if you wish to ask Laura additional questions once the recording has ended. Otherwise, I wish you all a very good evening and a wonderful summer. Thank you again for your participation in tonight's session, and we certainly hope to see you next session, next season, should I say, on OTF Connects. Thanks so much.